Okay, in this problem, we're going to find the shortest distance between skew lines. This has proven to be, well, when I first started teaching this, I thought this was a very challenging problem, and it took me a long time to understand it, and now I just think it's fun. So it's hard, it's difficult, it takes a lot of thought, so hang with me, and I'm going to do the best I can to explain it. So basically what happens is we have two lines, so I'm going to use these two pens for a second to show that they're skew. Okay, so if I've got, it's a little tricky to see, but they're not intersecting, okay, but they're not parallel either. Well, what happens is, okay, say this one's down there on the plane and this one's doing something like this. In order to find, okay, it's sitting, anyway, okay. In order to find the shortest distance, what we know that the shortest distance to this line is going to be perpendicular to it, and the shortest distance to this line is going to be something that's perpendicular to it. Like if you have a point on here, in order for it to be the point on the green to be in order for a point on the green to be the closest, the shortest distance, or in order to find the shortest distance to the purple, you need to find a line that's perpendicular to the purple. Well, then the same goes true for it also holds true the other direction. So what we need is something that's perpendicular to both the green and the purple. Okay, I don't know if you can kind of see. I'm trying to be perpendicular to this line and also being perpendicular to that line. Well, if I've got two lines in space and I want to find something that's perpendicular to both of them, hopefully all of a sudden you're like, oh, cross product. Okay, so what I need to do is what I'm going to need to find the cross product between the direction of these two lines and then find something that would be parallel to that. Okay, let's see if we can make this make sense. So what happens here is that any point, this is line 1 and this is line 2. So a point on the line 1, let's write this so we can see what this is x, y, z is equal to our position vector, how we got to the line, and then they're using t for line 1 times the direction. Okay, so there's 0 plus 1t for x. It's 1 minus 1t for y, and 2 plus 1t for z. Line 2, so the direction of line 1 is this 1, negative 1, 1. Okay, now we need to look at line 2, and sometimes it helps to first see this as a vector equation. Okay, so it's 3 plus, well, this is going to be s times negative 1, and then this one is negative 1, and then this is 2s, and then z is 4 and negative 1. Okay, so then the direction of L2 is going to be this negative 1 to negative 1. So in order to find the shortest distance, we need to be perpendicular to both of these lines, which means we need to take the cross product of the two direction vectors. So some of y'all have figured out that there's like a little shortcut, you multiply things. I never can have that. I never have that memorized. I don't choose to do it. I just do the I, and then this is what? Negative 1, 1, 2, negative 1. I'm assuming that you're caught up to speed and you know how to do all this. If not, go watch the previous videos. 1, negative 1, negative 1, 2. Okay, here's hoping I don't make a mistake, because in these problems, a little arithmetic mistake all of a sudden becomes a big issue. Okay, so this is 1 minus 2 is negative I. This is negative 1. Plus 1 is 0. Oh, that's nice. And then 2 minus 1 is 1. So I have the vector negative 1, 0, 1 is going to be perpendicular to my two lines. Okay, so now let's say I've got some point on, this is a point on line 1. Well, that point on line 1 has an x value of t, a y value of 1 minus t, and a z value of 2 plus t. And then I've got a point somewhere on line 2, and that has the point 3 minus s, negative 1 plus 2s, and 4 minus s. So all of that came from the fact that that's what they told me up here. And this would be, it's random x value, and it's random x value. And so, oops, sorry, you couldn't see what I was doing. So what I have here is this is any this is line 1, or line 1 is going through here somewhere, and line 2 is going through here. And I can't really draw them because they're skew, and if I draw them, then they're on the same plane and they're no longer skew. But what I can find here is I can find this vector between these 2 points. Well, I know that I need that vector to be parallel to what was, to something that's perpendicular to both of them. Okay, so let's find this. Let's call this point A. Let's call this point B. We'll find vector, I'm trying to minimize my negatives. We'll find vector BA. I don't know if that minimizes my negatives or not, but okay. A minus B. So then this becomes a T minus 3 plus S. So T plus S minus 3. And then I have A minus B. So 1 minus... That gives me a 2. Well, hang on. Let's do the T first. Negative T. We're subtracting away this. Minus 2S. And then I have a 1 minus a negative 1. So that's plus 1. That's plus 2. And then I'm looking at this one. This guy minus that one. I didn't really solve 2 anyway. So T minus a negative S is a plus S. And then I have a 2 minus 4 is negative 2. Okay, so this vector right here, in order to make this the shortest distance between these 2 random points, this vector needs to be parallel to the vector that's perpendicular to both of the skew lines. So what I want, in order for them to be parallel, I need this T plus S minus 3, negative T minus 2S plus 2, and T plus S minus 2. I sure hope I didn't make a little silly mistake yet. It needs to be equal to some scalar times negative 1, 0, 1. Okay, so if that's true, then that means that this vector between these points will be parallel to something that's perpendicular to both of them. So basically what happens is we don't know how far apart A and B are, but we know that this vector needs to be in that same direction as this one, because that makes it sure that it's perpendicular to both of the lines. Okay, so let me keep going. So now I have that I have a T plus S minus 3 equals negative K. And then I have a negative T minus 2S plus 2 equals 0. And I have a T plus S minus 2 equals K. At this point, I would probably, my challenge is that I'm home here for, this becomes plus K equals 3. I'm home with the coronavirus thing, and I didn't bring home a calculator, and that just really makes me sad. So what I would probably do, this would be equal to negative 2. This is T plus S minus K is equal to, move that over here, is equal to 2. Normally what I would do is I would go to my equation solver, and I would solve a system with 3 variables, and I would plug I would plug in 1, 1, 1, 3, negative 1, negative 2, 0, negative 2, 1, 1, negative 1, 2, and let my equation solver do it. But I don't have it, and I'm going to do it by hand. Okay, so maybe you're in the same, hopefully you're better off than I am. So what I notice is that if I take this equation already doesn't have a K, and if I use this top equation and this bottom equation, and I do elimination, then I can get a new equation without K. Okay, so then this becomes, it's T plus S plus K equals 3, and then a T plus S minus K equals 2. When I put those together, I get 2T plus 2S equals 5. And so now, using this equation and this equation, I have negative T minus 2S equals negative 2. And then 2T plus 2S equals 5. And I can do elimination again. This gives me T, those are gone, equals 3. Oh, okay, that's convenient. T equals 3. That's the first thing we care about. And now we need to find our S value. So I know from, well, here or here, I know that negative T minus 2S, negative T minus 2S equals negative 2. We just said T was 3. Add 3, so negative 2S is equal to 1. S is equal to a negative 1/2. Okay, so what in the world, what in the world have we done? We have we have found that when t is equal to 3 and s is equal to negative 1/2, this vector right here, this vector BA, will be parallel to a vector that's perpendicular to both of the lines. So what I can do is I can come along here and say, well, what's vector BA is now going to be the vector. Can you see everything I'm doing? Well, you can sort of see it. Okay, 3 minus 1/2 minus 3. Okay, so 3 minus 3 is 0. That's a negative 1/2. Negative 3. Negative 3 plus 2 is negative 1. That becomes a positive 1. No, that's 0. Oh, but think about this. This needs to be parallel to that, so this had better be a 1/2 if it's going to be parallel. Notice I multiplied this by 1/2, so this has to be 1/2. Let's check to make sure that we're right. Oh, sorry, you couldn't see. Can you see all of this on the screen? Anyway, let's see. Okay, 3 minus 2 is 1 plus a negative 1/2. 1 minus 1/2 is a positive 1/2. Okay, sure enough. So what happens here, this vector, notice, these are parallel. You can't see what I'm doing. These are parallel vectors. And so they're saying, what's the shortest distance? Well, this is the vector. Oh goodness, there's lots of details. Okay, this is the vector that went from a point A on line 1 to a point B on line 2, or point B to point A, whatever. I don't really care a whole lot. But this vector right here is the shortest vector we can create from one point on the line to another point on the line, because it's parallel to something that's perpendicular to both of them. Oh my goodness. Okay, so what their question says, find the shortest distance. Well, so we need to know the magnitude of that vector. And so the magnitude of that vector is the square root of 1/4 plus 0 plus 1/4. A fourth plus a fourth is a half. The square root of 1/2, well, that's 1 over root 2, which is equal to root 2 over 2. So the shortest distance between those two lines is root 2 over 2. So your final answer is root 2 over 2.